Sorry about that. I figured that that's probably part of my duties as recurring interviewer slash note taker is, well, may as well set norms around that. Right, I was going to say, if there's this trade-off, there's for sure this trade-off between how much does it improve capabilities versus how much does it improve safety? If you want to do sorry, still waking up somehow. If you want to do something about LLMs plus logical inductors bolted on, I guess the first thing I would want to see is a more detailed sketch of what exactly that looks like. And then after that, I still want to pick people's brains, mostly Abram's, on what the theories of change are in both cases. Like we have maybe not necessarily the best idea on how much capabilities increase or how much safety improves, or how much better safety guarantees you can get.
Yeah. I mean,
yeah, sorry.
go ahead.
Well, I just thought about like timeline theorems in general. Like they are like, so the assumptions we make and the theorems we prove are not like impacting that much. Like they are not impacting at all on the decision theory we take. In the sense that you said it yourself, like this is a sanity check, and like, well, like the sanity bug is now inside of the assumptions. Like the sanity of the proof relies on the sanity of the assumptions, and like I don't know, like at which point we should like say these assumptions are too insane, so we should reject this decision theory. So like, is there a threshold? Is there a threshold inside of your mind? Is there a threshold inside of team's mind?
Like how much more? Go ahead.
If it is a sanity check, then there should be a threshold at which like we say this is insane. Like that's the property of sanity check is what I assume, right?
Yeah.
What do you mean by insane?
So,
well, like it's the opposite of sane.
Okay, so my picture of this is like, like the proposed decision theory is up to this decision theory.
Sure.
And we've been like trying to navigate this, like the kind of difficulty presented by we can't do our Vingian sanity check, which seems like an important one because real agents have this Vingian uncertainty without doing UDT 1.0. But UDT 1.0 can't coordinate, and so that creates real problems for tiling and what kind of coordination assumptions can we make, all this stuff, right? And so like a very real possibility was that we're like, okay, this is all like, there's no way around this kind of divide. And now I'm like optimistic about this kind of messaging idea for getting around this. So that provides at least one picture of like how this could kind of fail, right? Where it's like, this like,
so like the Vingianity is the obviously sane thing for the proof to have, and if we are not trying long enough and not finding this proof, or even finding the contrary proof, like the negative result, then we are like, UDT is not for us. Like,
I mean, the negative
like that,
result, right? The negative result could be like, UDT really like the negative result could spell out some version of like there's no UDT that solves this combination of problems, right? If we can't get a positive result or a negative result, then in some sense we're still uncertain. But we can be becoming like increasingly pessimistic. And then where do we end up with, like, in that world, what do we do instead? I think a somewhat sensible thing to do instead would be, okay, updatelessness is actually like too much to ask for. So in some sense, this would be like an update against updatelessness. Like updatelessness doesn't provide at least an easy way of like solving these problems that we want to solve. And then we can kind of like narrow our scope and look for updateful tiling theorems, which are going to be making more assumptions because we have to give up on tiling in certain cases like counterfactual mugging. But maybe we can, tile in some some set of cases anyway. So I guess
I just want to have like give an observation. I think it's like I gradually noticed that because I've also been involved in some like more like research projects in mainstream academia, and I found that a big difference of the research we're doing here and there is that usually they don't question the assumptions so much because there's already an established methodology.
The paradigm.
And when
in
some sense
matter.
There's a paradigm, and also there's like less of a time limit in a way, right? Because in academia, for example, it's okay to spend 20 years proving some particular theorem about gliders in the game of life. Whereas we're like, look, the technology is progressing. We want to try to make a difference before it's too late. Like, and so it's like, yeah, there's not a paradigm, but also even if there were a paradigm, we would be like more concerned about whether the paradigm is correct than in normal academia.
It's actually like applicable to every part of academia. It's just that just that we are realizing it. Like they also don't have much time to do something.
Right.
But if they were, they wouldn't be doing the things they are doing. So yeah, I also like. So one quick comment. Maybe I'm just misunderstanding something, but like I've thought about the messaging proposal a bit, and it seems like it's just moving the bug to the messages. So you are becoming UDT 1.1. And like you are UDT 1.1, solving all of finding the good policy and sending the messages to the future version of yourself. And like just you are now becoming a giant lookup table, but you are not actively selecting a policy, but rather sending the messages about the policy. And like that's kind of the same to me. Like the hyper exponential search is still there.
Okay,
And maybe sorry?
I think I do disagree with that. I mean, I think there is a certain amount of passing the buck to the messages, in the sense that I want to assume that the coordination problem of like a language for the messages has been solved. But I don't want to assume that like the first guy, the first instance, like sends out these messages to all the rest of the instances, like doing this big search to solve everything. I want to instead say that the like yeah, there one thing is like the messages are suggestions, not commands, right? And so I want to leave room for improving on the message that you got. So maybe because of like limited ability to like limited computational ability when I'm sending these messages, I can see some coordination problems, but not others. And so I send messages to resolve those coordination problems that I can see. But then maybe by the time I get to that point where I've received this message, I can, having understood like the coordination problem that's involved, I can still find a better action than the one that was suggested to me. But my ability to do so still benefits from knowing that that other self that I have to coordinate with received a particular message. And so I know more about what they're doing. And so I can find like an improvement, right? So whereas like a self-modification would have to lock that in place, saying, I definitely do this. I've modified myself to do this.
So the idea here then is you send this message to yourself in the future, or like not necessarily like the future, but probably realistically the future in some sense.
Yeah.
And even though it doesn't necessarily fix that future self's response, you do at least get to have somewhat more. You can narrow down the possibilities on what it will likely do at that point, or like maybe even get a distribution over outcomes that is very different from one that the one that would exist if you didn't send the message. Is that right?
Yeah, something like that. Like if
It's
we
like
think about the like walk down the sidewalk without veering into traffic example,
Yeah.
it's like I can still maybe like see $1 on the sidewalk and bend down to pick it up, which I didn't anticipate before.
Okay. Ren, you had a question?
Yeah, I just wanted to ask. So I'm thinking about that, like there is a possibility to like that we are just in some sense becoming the UDT 1.1 and just obfuscating it. The way to realize that is like count the complexity of the search, and we haven't specified it anywhere. Like we are on the really abstract level. Would it be helpful for the team in this line of research to specify a class of the decision problems, which is like growing with n? And then we would see that like UDT 1.0 with a good prior solves this decision problem in like polytime, and the UDT 1.1 requires exponential time. And then we will look how much compute does like this messaging channel take, and like if it happens to be hyper exponential or exponential or something like that, then we're like, oh, we just passed the bug and haven't even actually solved any of the coordination problems. Would it be helpful to specify like this?
Yeah, I mean that makes sense to me. Where I'm at is still just trying to figure out how the messages work in the first place. And so I
Yeah,
feel
sure.
like I don't want to do that yet. But I agree that that's like a good way of measuring whether we've kind of accomplished anything, computationally speaking.
Yeah.
I guess I want to transition into like properly starting the. So like I had some notes basically on this topic that we're discussing. I'm trying to figure out some of how this messages stuff works. So Let's see if I can make them larger. Yeah, cool. Does somebody want to volunteer as the interviewer?
Sorry, for what specifically?
So
I believe Paul already volunteered.
Paul was the interviewer last time, so maybe
Oh. Well, I can be the volunteer.
Thanks.
Volunteer for volunteering.
I'm mostly just asking for when, because we're coming to the end of our time slot, and I've actually got to hard out like soon.
Oh,
I was expecting this was going to actually be an hour. Maybe it
okay.
shouldn't have been.
Yeah, I thought that you would be able to stay a half hour more. Yeah.
Usually I would, but usually at least be able to, but today I have something specifically scheduled for 11 to 12.
Okay. Well, we're still recording. Oh, 11. Okay, so you do have a half hour more.
I'm going, like, I need to actually physically travel to a thing. Otherwise I would have.
I see. Okay.
Yeah, apologies.
All right. Yeah. Yeah, I mean, I think I still want to go over this stuff with everybody else. And so, yeah, there'll be the recording. But this is just my attempt to, it's just an extension of like our meeting last week, basically. I'm just trying to like, okay, how do we incorporate messages? What are the type signatures? Like the stuff we talked about last week with like treating the effective policy is just somehow conditionally dependent on the chosen policy.
Yes.
But we're trying to incorporate messages into it.
Okay. Thank you. Yeah, I think you're good. I think someone else is gonna have to take over for interviewing for this then.
Yep. All right. Yeah. So, I guess this is going to be a particularly sloppy one for my editor to try to turn into something coherent, but that's okay. So I don't have slides this time. This is just like actually my personal notes. So like always, we have observations, and then like I've been doing, we have actions per observation. And then I'm doing this funny thing. I'm also interested in like terminology suggestions. I'm not sure what to call this, but basically the like, I'm calling it like the message policy, but I don't like that name. So somehow there's an assignment of messages to observations, right? Like for each observation, we receive a message. So maybe I should call this.
Sorry, for each observation we receive a message, and the message is an action.
Yeah, the message is an action suggesting like, here's what action you could take.
Or sorry, maybe it's too early to like try to make changes to this formalism, but is it possible to like message suggestion, action suggestion is going to be like rather a probability distribution, or this is like
so I think that's worth thinking about, but I'm going to deal with this in a different way.
Oh, okay.
But I'm going to take notes on suggestions. So my idea here is that out of these so-called message policies or message assignments, there's the enacted one that is the way, like the messages that we actually receive, right? So this enacted message policy can be probabilistic from the perspective of the agent. So instead of the messages suggesting probabilities, I can receive a message with a certain probability. So that means like when I'm sending a message, I can do something such that the recipient will go left with probability 0.5 and go right with probability 0.3 and stay still with probability 0.2 or something like that.
So you are like sending the message with the probability, or like you are changing the world in such a way that the agent is going to interpret the message the different way, or
No, yeah, the
that's
first.
probably not. And what was the first?
Like
You are
I don't want the interpretation of the message to be probabilistic. I want the language to be fixed and understood. But the messages themselves can be stochastic. So I can send myself a stochastic message instead of a fixed message.
Well, you are sending. Oh, okay, I get it.
And the reason for that is because I want to be able to handle stochastic self-modification. So I want to be able to have uncertainty over whether a certain attempted self-modification will work and what the impact will be, because that's realistic. And then separately, I want the messages to kind of exactly parallel the self-modifications, right? So I want, if I have this stochastic self-modification I can enact, I want a stochastic message that I can enact so that I kind of never have to self-modify. I can always send a message instead. So then,
sorry, why do you want to have stochastic self-modifications?
because the deterministic ones that we've been dealing with so far were always like a pretty big simplification of the problem. Like if I'm say I'm manipulating some sort of implement to change my circuitry, then I always have some degree of uncertainty about what the effect of that is going to be. And especially when we consider individual actions in the future, then if I have Vingian uncertainty in the first place of like exactly what action I'm going to take, so I don't even know the consequences of my current source code, and then I'm modifying my source code, then I shouldn't know the precise consequences of that. I should instead just have some distribution.
Mm-hmm.
So by this logic, should the policy itself be stochastic as well?
The policy is unknown, yes. Like, yeah, like UDT 1.0 in the Vingian case should not know the whole policy. So it should have some probability distribution over the policy.
Because if it is, it's going to like condition on probability zero events.
Exactly. Like, actually, yeah. So even stronger than the Vingian argument is that argument that like UDT absolutely needs to have policy uncertainty because otherwise it can't make decisions. Because otherwise it'd be conditioning on probability zero.
Well, in some sense, like philosophically, there like one argument follows from another. We have uncertainty over the future because like we don't know the decision, and we don't know the decision because we have uncertainty. So, you get what I mean.
Yeah. So then I'm thinking about, okay, like a policy type might be like observations and messages to actions. So I'm like, again, like, yeah, we could fold the messages into the observations, but I want to deal with them separately, so I'm just separating them out like this. The notation here is from functional programming. So if I just like if I instead wrote like this, which is what I've been writing before, then there's some sort of problem here because this is a little o in the A, right? And where did the little o come from? Like what I'm trying to say is that the type of the output, like the set of actions that we have available, depends on the particular observation, right? And so in order to do this, I need a dependent type. And in particular, I need a dependent function type. So a dependent function type, it turns out, is normally written like this, with this capital pi. But I wanted to highlight that here, like this doesn't look like a function naively to me, right? And so this is an alternative notation that is used sometimes that makes it clear that it's like very close to this type. Does that make sense, or does that not make sense?
I have a little bit experience with functional programming. It hasn't actually made sense for me then, and it's not making sense now. So yeah, sorry.
Yeah.
It's making a bit of sense. Like I get that like the action is like the message. Like, did you define the M anywhere?
So M is actually just also A0 or a little o.
Uh-huh. So,
I just wrote it as M there because it's the messages, but the messages are actions. So it's actually this one here.
Would it be weird to have like for an action to have a type of observation? I mean the little o. So action A type O small.
So you mean like AO equals O?
No.
Or AO
No. A, like the A, which is the type A, which is inside of the, so AO is like a set, right?
Yeah.
So a set could be also a type.
Yeah, I'm just thinking of types and sets interchangeably here.
Yeah. So like the set AO has the type O little. Oh no.
The thing is, little o is a term as opposed to a type.
Oh, so the terms and type are not the same. We can't have so we can't have terms and types. So a term couldn't be a type.
I mean,
Yeah,
that I think that's possible in like some crazy type theory, but I'm not. That gets into like type theoretic waters that are deeper than I know how to swim in.
Oh, okay. Like I only know about type theory from Lean, and there is like type, and anything could be like any object could be a type, and we can have an instance of that type, and this could also be a type. So like I told you about this hierarchy of types, and
Mhm.
I assume that that's how type theory works. Like everything could be a type, and seems like I'm wrong.
Well,
Like
so
maybe
if I have the type string, and then I have a particular string, let's say hello world, then how do I think of that as a type? That like I have this term.
I don't
hello
know.
world. Okay.
Well, somehow there is like a type of proposition, and this is a proof of a proposition. Like I have a sentence. There is a snow outside right now, and there is a type of this. Like this is a type, and I can have an instance of that type, which is a proof that the snow is outside right now. Like
That
logical
makes-
proof.
Yeah, that makes sense to me.
So I just assume everything could be a type, but yeah, it seems like I'm wrong. So yes, that's probably not relevant, really. Sorry,
Yeah,
that's
okay.
a tangent.
Well, yeah, I mean, you're checking your understanding. That's what you're supposed to be doing as the interviewer, right? So, yeah. So, yeah, messages are also of type A sub little o. So, really, we have this type. Now, then, this is from my meeting with Hannah last week. So, since we also have to send messages, and sending messages, we want to satisfy the argmax too. Like we want message sending to satisfy the same decision criterion of like the argmaxing. Then it's tempting to write that we like oops, what did I just do? That's weird. Anyway, oh, I see the problem. Okay, so I have collapsed some stuff here. So yeah, it's tempting to write that we get a message and we also send a message. So Hannah was pointing
When
out
we send a message, sorry, when we send a message, is
like
there
when we
are we
choose
sending a message in some particular observation, seeing some particular observation, or it is possible to send on any observation?
so I'm a little bit, I have several options for you. I'm a little bit like not knowing which order I should present them in, but basically this stuff under here that I had collapsed is like at every observation we might have the option of sending a message. So this is like so just to put the M's in so you know which ones are supposed to be messages. It's like whenever we send out an action, we also send out a message. But
Wait.
this doesn't quite
Wait,
make
why is the first cross O cross M?
because we receive an observation and a message.
So we can receive a message and then send one. Oh yeah, okay. You just said it. Sorry.
Yeah, no worries. So, but then I want to introduce the dependent types from before, right? So like we don't just have like an action type. So then it becomes something like we get an observation, we get a message, then we choose an action out of the actions available at that observation, and then we send a message that says, I'm sending a message to this particular observation, like this particular future self, little o prime, that suggests one of the actions out of their action set. So this is
more like O cross M to the A cross O cross M.
right, but again, I need to do dependent type magic because this type M depends on the type O, or it depends on the instance of type O. And so
that's what I wanted to say. Like this is different M's, like in the first O cross M to the A cross M.
Different M's. And this is also a different dependent type magic than the previous dependent type magic, by the way. So this one would be notated pi, and this one is notated sigma in the common notation. Because this is a product and this is an arrow. Just so you know. So this is like a pair, the type of the second element of the pair, depending on the type of the first. Or sorry, depending on the instance in the first. Whereas this is a function where the type of the output depends on the instance in the input. However, I also want to deal with sending messages to multiple receivers at once, right? So I'm like, I'm down here before I go in the red room and the green room, and I want to send one message to the red room self and another message to the green room self, right? So this turns out to be not too hard. We can just stick a list operator in there. Yeah?
Well, like when you do that, like, yeah, sure, you just stick a list operator. But when you do that, you actually becoming UDT 1.1.
Only a little bit. So like you have some. This is why I said I didn't. Instead of literally just sticking a list operator here, which would mean I can send messages to everybody, and I have this big combinatorial search. Instead, I'm like, I have this type M sub O, which is the type of the messages that I am able to send at this observation, which is some subset of the list of pairs of this type. So I have the option to send messages to red room self and green room self, but I don't necessarily have the option to send to all of my future selves. Similarly to how with self-modifications, we had this idea that you
so the assumption of limited self-modification, right?
like the assumption we have some self-modification actions we can take. We don't just have all the possible self-modification actions. Yeah. So similarly, we're like, we have some list of messages that we can send. Or rather, I should say some list of lists, some set of lists of messages that we can send.
A second objection, no, not really an objection, just a comment. Maybe it's worth thinking about like sending one message to everybody, because like for example, in the green red room example, it's enough to send one message to everybody, like pick the green room.
Mhm.
So like maybe that's how we should think about all of the decision problems. Maybe.
So in the green room, red room, it's enough to say to everybody, push the green button, not the red button. But we can also do like the XOR version of it, where like instead of you have to press the same button, now you have to press different button.
Yes, and maybe have to press different. So like maybe so there's no way around that. So like it's only dependent on how the decision problem is compressible. So like either you send one message to everybody, or either you send each one different message, or either you send very long message to everyone. And like realistically, how real agents work, they're actually sending one long message to everybody, just like having a memory, and everybody then can
I mean,
fast access that.
Yeah, this is a fair point, but I could counter that with like, when I set up a trigger action plan for myself. So for example, whenever I leave a building, when I'm at the door, I remember to check my pockets to see if I have the key or the key card for my hotel or whatever, right? I'm setting a memory for a specific time. I'm like, I visualize when I leave the hotel, I've got to check to make sure I have this card in my pocket. And then I don't think about it until I leave the hotel and I check to make sure I have the card in my pocket so I can get back in. Right?
So like those are some formalism, you say. So like you can view the one big message as like a sequence of like a bunch of small messages that are triggered by the observations.
Yeah. Yeah.
Yes, I agree with that.
So how should I write this down? Maybe.
That's actually going into the architecture of like the agent. Like how, if there were a fast way to like compute those, so like maybe you're sending a program that computes the message to everybody, and maybe no. So yeah, that's okay.
Yeah,
So
why do we need messages? Why don't we just dump everything into a big public memory?
yeah, so like I said at the beginning, that's just kind of I want to be able to take self-modifications and be like, you can send messages instead. And so I'm being explicit about the messages that are these like suggested actions so that it's kind of easy to work with. I'm not insisting that that's like the right decision. That's just my intuition for what's going to make the math easier to do. But
map to self modifications, like
right.
to replace self modifications.
Yeah, and so I agree that in principle these messages are observations, but I don't really know how to think of them as just being in the observation. Maybe there's a good way to do that, but it might be like still less convenient than separating them out.
One other option is to change the prior, but like that's maybe just becoming updateful.
Yeah, I don't think I want to change the prior. Yeah, I mean, I don't. to me, this is like giving up on the goal of like avoiding self-modification.
Well, I don't know. What is a self-modification anyway? Like,
Yeah. I mean, it is definitely subjective. And if you're changing the prior in some way that you understand well, specifically you're only changing the probability of policies, then that can be more principled and still like give you a much better grip on what this AI is doing than arbitrary self-modifications. So yeah, I don't know. Feel free to try that route if it appeals to you.
there's very many, like, too much routes we could take. So there should be like some way to select them. And I proposed one of them, like it's actually was like the way for me to select a route. Like, I definitely shouldn't select a route which would lead me just to like UDT 1.1.
Yeah. Or, I mean, UDT 1.1 is another route. Sam made an argument that we could try to study Vingian case even in the UDT 1.1 case if we don't assume that the policy selection works on tabular, like this big search space. Instead, we select algorithms and we're uncertain about what actions those algorithms take. But to me, that seems like
That sounds AIXI like.
it sounds. I mean, to be clear, AIXI plans ahead its individual actions.
Well,
It doesn't.
but it's considering the rewards, like the functions for rewards. It's like
Yeah. Okay. Yeah. So anyway, all of that was basically me trying to do what Hannah said that I couldn't do, to be clear. So like, in terms of like giving the types for the option where we have like sending the message in addition to taking the action. But I think I ended up going down the route that Hannah suggested for that, which was the like, so all of this is still like, these messages are not telling me what to do on my subsequent messages, right? It's only telling me what to do on my actions. So yeah, this is kind of like the thing that Hannah sent to the Discord last week. But just using some dependent types to be a bit more precise. But this isn't really what I want to do, because where I want to go is I want to deal with self-modifications as functions of actions rather than explicitly choosing self-modifications as we've been doing so far. In other words, instead of explicitly having, this is a self-modifying action, it specifically modifies this policy point. I instead want to say like, I take actions, and then sometimes those cause modifications. And I can't necessarily pinpoint one action that I take that's causing one specific modification, because I might have to take like a sequence of actions more realistically, and each of these actions has to happen in order for the self-modification to happen. Or like I said earlier, it might be stochastic, so I take some sequence of actions and each one contributes some probability to the modification. Or like there might be two different sequences of actions that I have to do, and if I do one of them, I get one self-modification. If I do another one, I do another self-modification. And if I do both at once, then there's some third, like, unrelated thing that happens. Yeah.
in order for us to test the new decision theory that handles all of that, we need to invent new decision problems which require multiple steps. And
I mean, this doesn't seem hard, right? Like opening a safe requires multiple steps, right?
yes, I mean, like, would they tell us the same type of stuff counterfactual mugging are telling us? Like, is it the same leap, like from the regular stuff you would give to CDT, and then like you're going to new like you are? Wouldn't you need to have like mega omega, which predicts omega and you, or something like that? Like I mean, like meta step, because like all other stuff. So, I mean, like step from CDT to type of problems to the new type of problems is quite a huge one. This is like a big leap, and maybe you have to have another huge leap in order for these multi-step problems to also start giving you something. Sorry, yeah, okay, but yeah, it is not going to be hard to imagine a simple ones, but it's going to be probably harder to imagine informative ones.
Yeah, I mean, for counterfactual mugging, the relevant self-modification I want to think about is like I can modify myself to give up the $10, right? If I am not the sort of person who would do that. So to me, it doesn't seem to introduce any kind of radical like super omegas or anything. I'm just it might take multiple steps for me to rewire my brain in the necessary way. Now we might want to consider like, what if omega copies me in the middle of that process instead of at the end or the beginning?
So you might not be finish your self modification. You might run out of time.
Yeah.
Weird. And you might be the sort of person that wouldn't self modify yourself really fast. You're like careful, and but you might want, in that case, if omega gonna copy you really soon, you might want to modify yourself to become the sort of the more reckless person to modify
Sure.
yourself. I'm not sure about the safety constraints on that.
Yeah. So yeah, it does introduce new problems for us to think about, but I mean, yeah, and it definitely introduces new difficulties. Like I think the idea that we might self-modify ourselves in steps, but we're still trying to create a proof that we don't self-modify. And because we're trying to do that for UDT 1.0, it seems like the natural approach is to prove that we don't take individual actions that self-modify. But now we can't necessarily pin self-modifications on individual actions. So now we need to make a bridge. Somehow, even though modifications are a property of the policy overall, like some overall policy has some probability of creating some modification, we need to kind of pin the responsibility on specific actions and not other actions in order to think about UDT 1.0 and whether it will Yeah, I realize we're over time also. So I could finish up if people want to go. I see the
I
room.
have about 20 minutes, I guess.
Okay.
I probably need to leave soon.
Yeah, okay. Well, I have this much left. So yeah, maybe I'll just I don't know.
Can you share the notes
Yeah, I'll
themselves?
just share these notes. Yeah, maybe let's wrap up here then.
Okay,
Have you guys
thanks.
watched the movie Arrival before?
I have.
With like the aliens that talks in circles?
Yeah. I think we should talk in circles. If in the if the future self is allowed to send a message to the past self, everything will be easier. I'm trying to think think about how it would be easier. I don't have time to offload the picture in my mind, but like in math, it's a common technique to like say in algebraic number theory to solve things first in the finite ring, and then try to lift the result up to z to the yeah. And
I think
so
it's completely unrealistic to assume that our agents will be able to see the future. I am
No,
not
no,
going
no,
to. Yeah.
no, it's just like it's like a formal trick that we assume that time is cyclic, or the causality in the environment is cyclic first, and see how good we could do, and after that, like try to
I don't have a lot of
retain at
experience.
most of the properties here when we lived to a linear time. Yeah. Okay, probably a bit crazy, but yeah.
Yeah,
I think
Yes,
if
it seems crazy to me.
that's
Yeah.
just the
I
natural
don't honestly-
logical conclusion if we want to send messages to me.
Yeah, I'm interested, but I don't actually see like what you're gesturing at.
Okay,
Like,
I'll try to work it out.
There might be relevance to like reinforcement learning setups where like the environment is actually cyclic, but not more than that. So yeah, sorry. I will wait until like you, Abram and Norman has a meeting and we'll talk about that, and then hear about that talking in circles idea.
All right. I guess I'll close it up here then. Thanks, everyone.
Thank you. Goodbye.